students, welcome to Veteach. In this video, we are going to discuss about strain gauges. What is a strain gauge? Strain gauge is nothing but an resistance whose output is changed according to the force or input applied. That input may be a force or pressure or strain or stress. Okay. The strain gauge is a primary transducer which is used for the measurement of strain and stress, displacement, force and pressure. I have just now told you, strain gauge is nothing but a resistor used to measure the strain of an object. When the external force is applied on the object, due to it, deformation occurs in the strain gauge. Deformation occurs on the shape of the object. This deformation will be both compressive or tensile force. That is nothing but the strain. It may be compressive or tensile. Compressive means it compresses the body. Tensile means it keeps on pulling out the body. That is called as tensile force. So it is nothing but a strain, and this can be measured by using a strain gauge. So whenever body is subjected to tensile or compressive forces, the shape of the body is deformed. So when compression means the shape of the body becomes decreasing, tensile means the shape of the body, that means the size of the body increases. So this can be measured by using a strain gauge. When an object deforms within a limit of elasticity, it becomes narrower or longer. Just now we have told it reduces size or increases. This is narrower and this is elongated. As a result, what will happen? The resistance in that end to end will also change. So the strain gauge is sensitive to small changes in dimensions of the object also. So for even a small change in dimension also, the strain gauge can measure that value. By measuring the change in resistance of the object, the amount of induced stress can be calculated directly, because the pressure applied is directly proportional to the change in shape of the object. The change in resistance is normally very small value and also sense the small change. Strain gauge has a long thin bimetallic strip. See here, it is a small thin bimetallic strip which is arranged in zigzag manner. What is zigzag? Zigzag manner is nothing but this. This is a zigzag manner. So a metallic strip is arranged in a zigzag manner. This is a non-conducting material and can enlarge in a small amount. Each can elongate or enlarge for a very small stress also. So these are arranged in the form of parallel lines. Okay. These are arranged in the form of parallel lines. The gauge is literally glued to the device by an adhesive. We want to measure the strain of a particular object. So by using adhesive means gum, we can attach this to that object and we can measure the output of by using the strain gauge. When an object shows that physical deformation, that is narrowing or elongating, then the electrical signal gets the resistance of the strain gauge changes and correspondingly an electrical output is produced. So the resistance of the material is given by R is equals to rho L by A. It depends upon the length of the material and the A inversely proportional to the area, where rho is the resistivity of the material. So when length increases, the resistivity also increases. When area increases, the resistivity decreases since it is inversely proportional. When resistivity increases, the area decreases. If P changes, the it is called as an piezoresistive effect. When the resistivity of the material changes, then we will call it as piezoresistive effect. So we have many types of strain gauges. Out of them, wire strain gauge, foil strain gauge and semiconductor strain gauges are there. Resistance of wire is of basically two forms. Resistance wire of strain gauge is basically of two forms. One is unbounded resistance wire strain gauge and another one is bounded wire strain gauge. First of all, unbounded wire strain gauge. It consists of a wire stretched between the points of an insulating medium such as air. It is stretched between these particular points. A wire is stretched and the medium is nothing but air. Here if you are placing it, here one point is there, here one point is there. In between those, the wire is stretched. The wire diameter is around 25 micrometers. The leads of the strain gauge are connected to one arm of the bridge. So the leads are connected to one of the bridge. So whenever there is a change in resistance, that is directly sensed by the bridge and the output is generated. So when will the bridge will be balanced? When there is no load or stress on the strain gauge. Whenever there is a load or external load or stress applied to the strain gauge, then the bridge becomes unbalanced and the readings are shown in proportional to the applied strain or stress. So here the stretched bounded strain, this is the force which we are applying. This is the movable platform, that is we can push it inside or we can take it outside. This is nothing but the body. This is stationary base which keeps on which is not moving, and this is a movable arm. This main platform is nothing but a movable arm. Whenever we are pulling it outside, the tensile stress is caused and change in resistance occur. When it is moved inside by applying some force, it compresses and and correspondingly a simple or change in output voltage is obtained since the resistance of the strain gauge changes. Next one is unbounded resistance, unbounded wire strain gauge. It consists of a wire stretched between 2 points in an insulating medium. So, in an insulating medium, between 2 points, 1 point and 2 point, a wire is stretched. The wire element will be having of 25 micrometer or less than diameter or less than it. It may be either 25 or less than that. 25 micrometer. The diameter of the wire may be 25 micrometers or less than that also. So, this wire will be in the form of again zigzag manner. The grid of the fine wire is connected on the carrier, which may be a thin sheet of paper, bakelite or Teflon. So, this is placed on a carrier such as a thin sheet or bakelite or a Teflon sheet. Teflon is nothing but a type of material. So, the diameter is used for looping back forth of the carrier or mounting plate, which is cemented to the member of undergoing stress. So, this resistor is cemented on the member which is undergoing stress. So, in this bar I am applying some force F. What will happen? It will move somewhat downwards. Whenever it is deforming its shape, the strain gauge senses that change and corresponding output is produced. The leads of the strain gauge wire are connected to one arm of the bridge. So, these are the leads. These are connected to the one arm of the bridge. So, whenever there is a change in resistance, it will be sensed by the bridge and output is produced. Initially, the bridge will be in ideal condition, that is no load condition, null position. Whenever there is a change is occurred in the strain gauge resistance, then that correspondingly the bridge will change from balanced to unbalanced condition and an output voltage is produced. So, when an external load is applied, the resistance changes and the bridge becomes unbalanced, resulting in output voltage which is proportional to the strain or external load. So, whatever may be the strain, it gives the direct result in terms of voltage. Strain gauge using in bridge medium. For one of the arms, we will connect the strain gauge and for other arm, we will connect dummy gauge. Okay. So, resistance R1 will be variable and R3 will be fixed. So, whenever we are connecting, initially it will be in balanced condition, null position. Whenever a whenever there will be a change in resistance due to the deflection of deformation of a body, then the bridge will tilt from balanced to unbalanced position. So, the bridge may be AC or DC activated with no input, bridge is balanced. Input load or force is applied to active strain gauge. Dummy gauge is only for temperature compensation. So, this is used for temperature compensation only. No other use of this dummy gauge. That's why it is called as dummy. No input is given to the dummy gauge. The bridge is now becomes unbalanced. Why it becomes unbalanced? Because we are applying some force or pressure to the material attached to the strain gauge. Then the output voltage is directly directly proportional to the input. So, in this way, by using strain gauges, we will measure the physical quantities such as force, stress, strain and so on. Okay. I hope you all understood it, students. Thank you.